Assalamualaikum, myself Fanika Imran, registration number 21TE54. This is our lab number 9, and in this lab number 1 is it's given that we have to use the winding method and we have to find the frequencies. So basically in the task number 1 we have to plot the filters in the time domain and with respect to the magnitude response. This is given. Now move on towards the code. uh, this is our code, and in this one this is a given sequence, and we define the length and x label and y label. Now let's run this function. This is the graph. This is the impulse response of the filter, and all these are the discrete time values that are given in this graph. So now we have to find the magnitude response for n is equals to 1024. Now again we see in this figure, this is the graph for finding the magnitude. Moving on towards the next lab task. Next task is use the winding method like Hamming, Henning and Blackman, and we have to find the responses. First of all, the coefficients are given. These are the coefficients, and the length of the winding is 512. This one is also given, and we used all the Blackman and Hamming filters to find them. Let's run. This is the output, and the first one is for Hamming, the second one is for Henning, the third one is for Blackman, and in this case the magnitude response of Hamming is best. Now the second lab task is the signals are given, and we have to plot in the frequency and the time in the frequency domain. Or and fs is also given, sampling frequency, all this data is given to us. Moving on towards our code. As we know, all the data is given to us, so we just have to plot the signal in the time and the frequency domain. This whole part was given to us in the question, so we have written it same. You can see this one. Okay, so as we have to find, we have to plot the signals in the time and the frequency domain, so let's run this function. We will have the three signals here. First one, this one is the first one, and in the first one the signal is in the time domain. In the second one, this is the magnitude spectrum of the signal, and third, this one is the magnitude response. Moving on towards our last lab task, that is lab task number 3. In that lab task, what we have to do, let's see. Okay, so we have given some audio signals, and we have to discard the required frequencies that are given to us. So we have to remove the low and high frequencies from this task. We have written the code, and now let's run this function. We have, first of all, we have to save all the outputs here. In the MATLAB, we have to save it, and now we have to run our function.
You knew I would not allow it.